This is a flip video about the different types of reactions. There are 5 types of reactions we're going to be talking about. Synthesis reaction, also called combination reaction, decomposition reaction, single replacement reaction, double replacement reaction, and combustion reactions. Double and single replacement can also be called double displacement and single displacement. It means the same thing. The first type of reaction we're going to talk about is synthesis reaction, also known as combination. In the word synthesis or combination, it means things are coming together to be made. That's exactly what a synthesis reaction is. Let's look all the way at the bottom first at the reaction seen under example. Hydrogen gas and oxygen gas come together to make water. So we say an element and another element combine together to make a compound. In other words, A and B come together to make AB. So if you look at my funny little picture here, you've got a guy and he's kind of hot for that girl, and then they come together and they dance. So they were once separate entities, separate people, and they've combined together to make one couple. That's what a synthesis reaction is. Next, decomposition reaction is the second type. And if you think of the word decompose, it means to break down, like, a body that decomposes, or maybe an animal that's decomposing. It means to break down. So if you notice here, we'll start first with our funny picture. Our lovey-dovey couple who are together and holding hands break up. And now the guy is left all alone and the girl walks off. That's exactly what's happening in our reaction. So let's look down below at our example. You have water, which is a compound, right? Bonded together. And once the reaction is done, on the other side, the products, you get hydrogen and oxygen both separated out. So what was once AB is now decomposed into A plus B. A and B are now separated. So that's all you want to do is take the joint reactants and separate them out into their individual pieces. So a compound turns back into its basic elements. Next, single replacement. So let's look at our funny picture again. You've got a couple and they're dancing. And this guy taps on Mr. Hot Pants over here with his black pants, taps on the other guy and says, can I have this dance? So poor B walks off, and now she's dancing with Mr. Hot Pants. So one single guy came and replaced another guy, and that poor B is left all by himself. That's exactly what's going to happen in single replacement in our reaction seen below. So let's look at the example. You've got magnesium, which is Mr. Hot Pants up there, and the couple hydrochloric, HCl. Okay, so magnesium taps on H's shoulder and says, beat it, I want to dance with chlorine. So now on the other side, you see magnesium is dancing with chlorine, and poor hydrogen is left to walk off all by himself. So magnesium replaced hydrogen. One single thing replaced another, single replacement. Always on the flip side, you have a new couple being made and one thing being bumped off. So a compound plus that poor element that got bumped off. In this example, known as double replacement, in our funny picture, if you notice, you've got couple AB dancing together. Then you got CD dancing together. What happens is on the flip side in the product, they just switch partners. So now guy C is dancing with girl B and guy A is dancing with girl D. So it's basically a switcheroo. The partners just switch. So if we look here down below at our chemistry reaction, you have boyfriend-girlfriend. So let's look at it. Silver and nitrate are dancing together. And then in blue over here, you have potassium dancing with chlorine. On the other side, silver and chlorine decide to now dance together, and potassium and nitrate dance. So the partners just switch. And what happens is the cations swap out. So let's take a look at what that means again. So if you pull out your periodic table, and if you remember, cations always come first in a reaction. So let's start back with our purple again and look at it. AgNO3. Ag is the cation. It is the metal. It's positive. Let's look at the blue one. K is the metal. It's positive. So we'll pretend the boys are the cations seen here. The boys are going to swap places. So Ag swaps places with K. So do you see that in the products? Ag has now taken K's girl, which is Cl. And K is left dancing with NO3. NO3 and KCl have new partners. And our last reaction is known as a combustion reaction. And sorry, there's no funny picture for this, but this is kind of easy. A combustion reaction kind of always looks the same. It's very similar. I like to call it like a cookie cutter reaction, meaning you can almost always identify them because there's very similar things going on. So if we look here in red written underneath, you always have something called a hydrocarbon bonding with oxygen. So what's a hydrocarbon? If you hear the word hydrocarbon, you hear hydrogen and carbon. So it's a compound that has hydrogen and carbon in it. And it's always reacting with oxygen. So if you notice, this hydrocarbon is CH4, but it could have been C2H6 or any combination of carbon and hydrogen bonded together reacting with oxygen. It always reacts with oxygen. Now, the products it makes are always the same products. No matter what, you always get CO2, H2O, and heat. In other words, you always get carbon dioxide, water, and heat. So we call this reaction also that because it releases heat in the product, it's known as an exothermic reaction. Exothermic means heat is being released in a reaction. So whenever you see heat being released in the products, remember products on the right-hand side of the arrow, you could say this reaction is exothermic. But to classify it, the name is combustion. Exothermic is just like a description you give to it, like an adjective you could say. So again, you have some sort of a CH compound reacting with oxygen. Who cares what kind of CH compound you have? Sometimes a CH compound even has an O in it, an oxygen. And it's reacting with oxygen, and you always get CO2, H2O, and heat. That's the end of our 5 types of reactions.